Okay, so hello everyone. My name is Dimitrios, or Dimitri.OS as is my nickname. And I realized after publishing our first game that I'm quite a lazy developer. So that's why the presentation is called CI/CD, or Continuous Integration, Continuous Delivery for Lazy Devs, which is basically a presentation for myself. So what problems, where or are the problems of a lazy dev? Right? You start and you finish, let's say, building the game in the meaning of constructing all of the mechanics, but then you have to create the actual builds for Windows, for Linux, for Mac, for WebGL, for Android, for iOS. Should I keep going? Because we can also add the different architectures, CPU architectures, and etc. And that's a manual task where you click a button, wait, click a button, wait, and that's quite annoying. And then you have another problem. Like, for example, I made a library to handle character stats, but where was it again when I wanted to reuse it? It's like, searching forever for that lost piece of code. And then, oh, I found it. But oh, wait, it's the old version. I had changed it somewhere in one of the projects and it's better now, but I cannot find in which project it is. And yeah, quite annoying as well. And then let's say you have really completed everything. Also, all of the builds are existing. Now is another part. You need to go to each of the pages like Steam, itch.io, the Android, the Apple Store, and you need to log into each of them, then find where to put the upload, the bin and stuff, and where to put the builds, and waiting each time to upload it if you have a good connection, and that again can become quite repetitive. And then what happens then? You're like, oh, I'll push update tomorrow. I guess I'll have to write that library again. When or what did I even update this time? It's completely forgotten what you even do. And then after you finally released, you're never touching the code again because you're afraid to break it. And let's say something goes well and you want to support more platforms, like, oh no, I have to make more builds and upload to more platforms, like kind of don't want to do that. So most of those issues have been solved with CI/CD for myself. And I'm going to do something a little bit crazy here. I'm going to do a live demo. So I have this beta branch here where I uploaded the new version or committed the new version with the changelog and added some translations and stuff. And with a single push of a button, I'm going to push this to my CI/CD pipeline. And I hope everything goes well. 2 commits have been pushed. And now I can just go here to GitLab. Let's go to the pipelines. And I see that they are already running. With the one that I added the translations, I can click on it. And it's going to build Windows and it's going to be Linux. I've removed the other platforms to just save a little bit of time. And after it's done, it's going to set up the password for Steam automatically so that I don't have to log in. And then it's going to push to Steam automatically. So I don't have to even open the Steamworks UI. And every second they're done, it's quite nice to not be in this UI. So now I can take a look at the Windows build. Is it completed or not? And I really hope this does not look good because it shouldn't be loading so long. I hope nothing crashed. Okay, seems fine still. It's just running. Okay, so Windows is completely built and Linux is still building. Let's see the logs, and I can check here all of the logs from the build process. I can see if this is a Godot project, so I can see here loading resources, theme, everything's fine. And there was once, for example, a bug where the DLL file was not built correctly. So I even added a check here. Where is it? Yes. If this folder exists, then it should echo that there is a success for the C# building process. If not, to say that it failed. And I can see that everything's working well. And if I reload now, hopefully it's gonna, now it's on the, what it's called, pre-deploy stage where it's checking up the password. Let me see how much time I have. It's 8 seconds, 7 seconds. It started, setting up the password now. I guess we can go over to questions maybe, and we just see how it's building stuff. So, thanks for the compliment here that the build process is amazing. It's actually really nice. I can admit that I'm happier now that it exists. I guess I'm reading the questions from the chat. CI/CD hits all of the happy parts of my brain. That sounds good. Making a build mid-talk shows true faith in our CI/CD setup. Yeah, yes, actually it is a little bit scary to be doing this, but it kind of works. Also about the commit messages, I have something called, what is it called? Conventional commits something. So it basically, whenever I do a change, I run this script and it automatically, maybe you can use this now. It's just interesting. So, readme. So this thing here, commit, tag, and version. So let's say I do something amazing, and like a few scripts here, you can see that my commits here are like chore. These are not being shown. But for example, if I have something here like fix or feed, it's categorizing it as features and fixes. And then I can just, for example, let's say I want to release a new patch. I am just hitting this thing here, and let's see, terminal, or no, yes, I think it's terminal. So clicking on it, and it's automatically creating a new version for it. It searches for all of the changes and packs them into the changelog. So, for example, these were some changes from the past, and whoa, what is it doing? Why is it scrolling? Okay. Yes, any case, these are all of the changes, and it automatically generates like a changelog, and it automatically puts it also into my game. So I don't ever write new changelog. It's always automatically happening based off the commit messages. So conventional commits I can recommend because it's the standard to, how to format your commits so that in theory such tools can work nicely. 4 minutes for talking, 3 minutes for talking. That is pretty nifty. Yes, I can share all of the links generally. The conventional commit style is optional, really. I didn't know that. But it's in any case, it's working for me, and it's it helps because then I can categorize things like features, bug fixes, and I will customize it a little bit so that I can have different areas for balancing and stuff like that. And when it shows, maybe I can show how it looks like, hopefully inside of the game. Yes, I need to open up Steam. Let me maybe just ignore it. No, the achievements are not going to work, and I forgot to open Steam. I could technically open Steam itself, but maybe not now. Yes, that's the link for the conventional commits convention. Yes, maybe I can just stop streaming for a second, open up the thing from within the Steam page. Or maybe I can actually show something that's also neat. 1 second. Okay, so one more cool thing, and that's hopefully going to be the final one that I can show, is the project. It references a lot of smaller projects, like for example the Achievement Manager. So basically, each of them are separate small class libraries written in C#, and I can just reference them. And perfect. So I can just reference them inside of my code. Basically, I have with GitLab CI/CD, you can deploy the packages of smaller projects. So, for example, this core project becomes a separate module, and then I can reference it in my NuGet packages. So here is like this achievement manager, changelog parser, easy UI. I have done some other stuff, and that's basically it. So there's even more to that to make it easier. feel free to leave any questions for later. I can also answer, and I'm happy to share stuff. Yeah, that's it.
There we go. Okay, I'll just get started. Hi, I'm Alice Bottino. This is my talk, Talentless Hack, a self-taught tech artist guide to making games that can actually look good. First, why anything I say matters. I have been an industry professional for like 4 years, but I've been making indie games for like 11 years at this point. And I've released a little over 20 games, depending on how you count it, in that time. And I am entirely self-taught, both in programming and then eventually in art, just through the act of making games. Not through school or anything else, just making stuff. First of all, this talk is general advice. If you feel like you don't have the artistic skills, or you're not an artist, you're not someone who can do that kind of thing, you can. And this talk is for you, especially the programmers out there who think they can't do it. This is for you. This is based on the experience of me and others who are self-taught artists and technical artists around me. So it's not just my experience, but other people I've talked to about this. And it's more about mindset, not really about technical stuff. This talk isn't about technical or like how you do anything nitty gritty. That's all stuff you can learn on the way. And it's not career advice for getting into the industry. Getting industry jobs is a constantly shifting thing, far more complicated than I can talk about in 5 minutes. So I won't, but this is just about making art when you feel like you can't. So it's a 3-step process. Step 1 is make whatever you can. Whatever you can do right now, even if it's spawning cubes in Unity and putting a material on them. If that's the only thing you can do, just do it. You don't need any skills other than what you have right now. You can do it. Just make what you have the ability to. I've made multiple games just with the Unity cube, and some of them I remember very fondly, which is awesome. So do that. Make things that you like. This is step 2. If you like it, make it. It doesn't matter if you ship it in a game. It doesn't matter if anybody else likes it. It doesn't matter if you do it the right way or the wrong way, or if you're taking something from the asset store, or you're doing some horrible nightmare. It doesn't matter. As long as you like it, that's what matters. And then secondly, make things that you like to make. If you're having fun, you will be learning. That's all that matters. Don't worry about what you should be learning or what you should be doing. Just if you're enjoying the process, you have to enjoy the process. That is the most important part. Things that you shouldn't worry about is doing anything the right way. Don't worry about poly counts. Don't worry about topology or edge flow or any of that nonsense. Anyone who yells at you about performance or practicality or best practices, okay? None of that's fake. It doesn't matter. It will probably matter at some point, but when it does, you'll know. And then you can learn then. For now, don't care. Just do whatever. Things that you should do, I like to call these hack tactics because I am a hack. Only make things with cubes, as I said. Legendary, call it an art style, call it a day. Monochrome, you're struggling with colors, pick 2 colors you like. That's it. That's all you need. Rendering things at low resolution is a great hack. If you're only using cubes or your 3D modeling is bad, easy solution. If it's at low enough resolution, no one can see your 3D models, so that they don't look bad. And bloom. Oh my god, bloom is a magical sauce. Pour it on everything. It's like it's 2008 and you're making an FPS game. Just bloom, 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 bloom. Like at some point it'll be too much, but you'll know when you get there. But you can use more than you think you can. And just make stuff. Even if you don't think you're good or you can't do it, just do it. And you'll get better at it. And you need to fall in love with the process of getting better. Don't worry about what other people like. Worry about what you like. Worry about what you like making, and worry about what you can do right now, and fall in love with that. And eventually you'll start making things that you genuinely feel proud of to show to other people. And it can just make you feel awesome. Yeah, and then you learn. It's great. So that's it. That's what I got. Thanks for your time. And if anyone has any questions, I'd love to go over them. Uh, let's see. Uh, Programmer doesn't know much about art? Yes. Chloe, yes. It's okay. You don't have to know anything. Just like stuff and make it, and that's all that matters. Um, this is for me for sure. Telling me games don't have to be drawn by a 3-year-old. They should be drawn by 3-year-olds. Honestly, yes. If anyone has ever seen the game Dream Quest, that game actually it looks kind of bad at first, but the longer you play it, it starts to grow on you. Um, as much bloom as you can stomach. Dab emoji. Yes. Okay. Bloom. I love Bloom. I love Bloom so much. Um, yeah, worrying about best practices is the number one way of never getting anything done. Just make stuff. Like when it'll become a problem at some point, but you can deal with problems. We're game developers. That's like our whole job. SAO is a great shortcut to good graphics. True. Very true. This is a talk for me and learning 3D. Yes, 3D seems scary, but I promise you, I actually think it's way easier than 2D because you can kind of hide behind post-processing and stuff. Um, uh, how do you avoid hating your games over time? It's the main thing that kills my projects repeatedly. One, be kind to yourself. Um, uh, just like you just have to. It's okay if it's not perfect. And also, this is the real secret. No one will tell you. One of the most important things to making games is finishing things. One of the other things that's important is not finishing things. If you're not having fun, don't like, especially when you're learning. Like as like making things that you like is far more important than like getting other people to see it, especially when you're building like your own taste. So like if you make something, especially if I go up, um, these are all projects that have never shipped and probably never will. But I learned a lot, like learning shaders or doing animating, trying to put 3D models in a 2D space. It was all a lot of fun. Never shipped any of it, but who gives a shit, right? Um, uh, 2D hack is pixel art. True. Yeah, you can do a lot of like pixel art type things with 3D. Legally distinct Sly Cooper. Yes. I don't know who you're talking about. I've never played a game with that man. I don't know. Anyways, next question. Um, building your own taste. Hello, hidden gem. Yes. Yeah. Like, who gives a shit what anyone else thinks looks good? Just make what you think looks good. And eventually, if you're confident enough, other people will start to think it looks good too. Um, yeah, be kind to yourself, quoting a counselor. Yeah. Uh, the especially like one of the hardest things of learning art is that like as we consume art, we start to turn a critical eye and decide what we do and don't like. And it's really hard to stop turning that critical eye on what you're making. And it makes it really hard to make art if you are older and you have skills and you don't know. Um, and it's just like you just got to learn to be kind. And like the things you make aren't going to be perfect. But just try your best. And also, sometimes you'll hate something because you're like, oh, it's not good enough, whatever. Leave it, come back to it a week later. You'll look at it and you'll be like, actually, it wasn't that bad. I was being really harsh on myself. Like, it could be better, but it could always be better. And yeah, uh, need to start getting back into tech art and doing some proper stylized stuff. Yeah, tech art, especially if you are a programmer, tech arts is like, I don't know how to paint. So I taught the computer how to paint. That's what I do. That's actually my day job is I don't know how to paint. So I just make the computer do it for me. But it's a lot of fun and you can make art that way. And it's so fun. 30 seconds. Okay. Last minute questions. If anybody has anything. What are your thoughts on AI generated art? AI that makes things easier to make for people is always cool, but if you are prompting a computer to make something and then you just like that thing, you are not a creator, you're a consumer. Which isn't bad, but it doesn't make you an artist. I like things made by people. So make things because I think people make cool things. Yeah.
Hi everyone, this is my talk Beyond the Basics, how to make shell commands useful. This is a talk that is theoretically aimed at people who have used a shell a little bit, run individual commands but never gone further. But really I hope this is for everyone who thinks, I've got little problems that are tedious to do manually, there's no need for me to actually automate the whole thing. This is a middle ground that can solve the problem for you. Why am I talking about shell scripting? Well, for a start, you already have one, and it will take you no time at all to get set up and going. It's incredibly quick. You will have PowerShell or CMD if you're a masochist for Windows. You will have Bash or Z Shell for any Unix system, possibly others, but if you've got a different one, you already know enough for this talk. And it's a really lovely middle layer between I have a thing to do manually, but I don't want to set up like a Python runtime environment or a little node project that involves npm. You have this middle layer that's very quick to open up and crack on with, and because of the way the problems are solved, it's a very, very fast way to type as you think to solve your problems, which you might see in a minute, depending on how much time I have at the end. But I'd like you to imagine a scenario. You've released your game into the wild, but it has a game-breaking problem. You can't reproduce it, but you've had playtesters who can. They can submit the error file, which I'm pretty sure every game engine will give you somewhere, a log file, but they are huge. If you were only going to solve this manually to think, okay, well, let me find all the errors and see what there is, it'd take you ages. You pop open the file one at a time, Control F for error. God, okay, copy paste this into Excel, have a little counter for how many times it's appeared. Tedious. Not the way to solve the problem. But the problem can be broken down. Just think, what are the smaller individual steps we can talk about here? You have get the file, filter for the errors, count how many each time they appear. There aren't sound effects, it was just the click when I started the little macro. One of the first things to think about if you want to try and make working in a terminal more kind of fluent, more powerful, is command chains. There are three main ways to... Oh, interesting, I've used less time than my macro says. I can't code VBA. Don't try it, it's awful. There are three main ways to pass data around. I'm more specifically looking at Unix styles here. PowerShell doesn't pass files, it passes objects, but regardless, the one I want you to focus on is this bottom one here. The same sort of concept exists in PowerShell, but for Unix systems, this pipe command says, take the output of command A and put it into command B. And that can happen as many times in a row as you like. So how do we use that to help us? Well, take these three steps we just talked about. Take file, filter errors, count. We can use smaller individual, importantly, pre-existing commands to do this for us. There are lots of different ways to do this. All of the experienced kind of terminal users will call me out for the different ways I'm doing this, but this is possibly the most straightforward way to get started. Cat is a command that takes a file and prints it out to the terminal. If I cat this application log, you can see it starts with game init started, and then there's another line that says I'm loading assets, and blah, 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 blah. And you finally get an error somewhere in there that says, hey, something's gone wrong. That's not massively helpful in and of itself, but step one, we've got the file. We can use the pipe command to put this output, instead of going into the... I've just noticed the timer go from 4:58 to 4, so that's fucked. Take this output and put it into the next command. grep is a command that we can use to filter the input to only include lines that contain ERR, case insensitively, to just get our errors. Okay, we're getting somewhere. Next up, we can use this natty little combo to sort those lines alphabetically, so all repeated instances are next to each other, and then unique collapses them down and gives you a count of how many times they appeared. You can see here the error field foo is not defined appeared in this file 400 times. The player had minus infinite health appeared 50 times. Also, they picked up berry because it doesn't know it's an error, it just knows it contains ERR. Just to bear in mind. You could even, if you wanted to go one step further, put all of this into another sort to just get those in numeric order from the most recent. But honestly, you probably don't need to do that bit. So you can take this long, complex manual process and actually, with relatively short steps, get somewhere that's painful to do manually, but you don't need to set up like a runtime environment in Python to do it. Can I have a time check, please? Because I can't trust my macro anymore. Okay, cool. Running a little bit behind. But you might be thinking, I have to do that every time? That's tedious. Two things. One, when you're used to it, writing this line out takes about 8 seconds. I timed myself. It's not long to write this when you get used to it. But more than that, Bash and Z Shell and PowerShell are scripting languages, which, to avoid the academic side of the discussion, are basically the same as programming languages. They have variables, they have loops, they have ifs, and they have functions. This is going to look real boring following from Dimitri's talk, but I use a CI/CD script in my Unity project that does two things, and it just wraps other logic because all of these are individual steps. Function brings them together. This is a function, itch.io_publish, that, as well as writing some stuff, and I've hidden a few bits of information, calls butler push to push a variable, build target, to a project and a channel. We'll come back to that. A separate function here, Unity build, runs the Unity executable in a specific way because every command is kind of also available through the terminal, asterisk. But what this does is it calls the Unity execution for the building logic without having the editor open. And I can run Unity in the background to just compile my application. And those two are used with this, which don't feel you have to read. I will explain it later. What this does, and this is in all of my Unity projects, I run my PowerShell script. It takes whatever my source project is and duplicates the whole last thing with a hyphen snapshot on the end. This is a clever copy command that means it only copies changed files. It then moves that all to the snapshot directory so I can keep working on my game, very useful during game jams. And then it can say, okay, I will build for WebGL and then build for Windows and then build for Linux. And then once that's done, it will upload for WebGL and upload for Windows and upload for Linux, all to whatever this happens to be for the project. And so I can run a PowerShell script, keep working on my game, and in the background, a different thread is building all the platforms, uploading all the platforms. This is quite manual and hand cranked. Obviously, there are ways to optimize this, but that is just a natty little way of doing this. I've massively run over time because I had issues getting started, but does anyone have any questions? These are a couple of little ways that using a shell can make life a little more straightforward. I hope you found that useful. And I am always happy to jump on a call and walk you through setting some of this stuff up if you'd like. How could you set this up for Unity? This is just a PowerShell script, so it will work natively. What I do is I have a folder in my Unity project, and when I want to, I just press the go button. These are separate PS1 files with some extra bits I've removed here for brevity, but then you can import from one PowerShell file into another. So it's kind of like separate batch files, but it's PowerShell. So I define this function and I call it here. Any advice on resources to learn commands and techniques? Yes. This is a hugely well-trodden path. I can send people links if you want the academic style of here's everything or a guided walkthrough, whatever you prefer. Thank you very much, Kanmuri. But there is huge amounts of information available online that you can walk through this with. If you are using this on Mac or Linux, please don't use the base terminal. It's painful as hell. I highly recommend something called OhmyZSH and iTerm2. But again, hit me up. This is kind of a huge part of my job, is this style of information sharing mentoring. always happy to walk through on a call if I have the time. So please do shout out for me. How are we doing for time? 10 seconds? Yeah, I hope you enjoyed it. There's one more thing I can talk about. You've seen in the channel where I have a build script that can automatically add a version tag to a game. That's really useful, but there's nowhere near enough time to talk about it. Thank you, and I hope you enjoyed.
Hello, I am the Chief, and this is a quick explainer on why prototypes are far more valuable than you think. So I'll start with the "you're doing it wrong" bit. Everybody treats prototypes as the thing you do at the start of the project. This is not the way it needs to be. You, in the most pretentious way possible, making a game is a journey of discovery. Your game is a series of decisions. And the quicker you realise that, the more flexible you can be, the better a game you'll make. It's not as simple as idea to prototype to real project to release. You run into questions, you make decisions, and you don't want to just make those decisions at random. Sorry, I am a little bit ill at the minute. So prototypes are how you make these decisions, basically. Prototypes are really good at answering questions. They can be questions about your design, controls, marketing, communication, anything really. Prototypes, again, potentially become your compass. They help you find your way through this decision tree. They can even help you figure out what questions you need to be asking. So I will use Polyfury as the example, as always. On the left, you have what it originally looked like. That was my version 1, what people would typically call a prototype. And on the right is what it looks like now. A lot has changed, like an awful lot. I prototyped absolutely everything. That's input, scoring, visual style, when and where I use random number generation, and I even added a giant laser that completely changed the game. Each one of these was a focused experiment designed to answer a specific question. So how did I do this? How did I actually do the prototypes? So the first thing you want to do is make a branch, copy a folder, whatever. Just make a separate version of your project that you can break. Then you fuck around. Genuinely, just go ham. It doesn't matter what you do. It doesn't matter how you do it. It is just, you just go. Which, to me, is the most fun part of game development. Just making stuff up as I go along. So then you find out, get other people to test it. You are your own worst enemy with this sort of thing. If you've got an idea in your head and you really like it, then that's gonna influence how you continue. So you want to get it in front of as many people as possible. Ideally, people outside your social circle. Just get it out there. After that, you kind of take some time to digest it. You work out what people are actually telling you, because people aren't very good at saying what they're telling you. And you need to work out whether or not you actually care about that. And then after that, you delete the branch. This is the most important step for me, because it stops you from thinking about what you're doing too much, because you know you're immediately going to delete it. You're not trying to write it well. You're not, thinking about how everything needs to fit together. That comes afterwards. It doesn't really matter how you actually do the thing. Just do it. And that might not look like literally deleting the branch, but having that freedom is so important. And the cost of doing it is really, really low. You don't need assets. You just need a day or two to put something together. It doesn't even have to be in the same project. It can be on paper. just anything that makes it easier to try something out. So after that, if you think the prototype's positive and you want to add it to the game, you've already got an idea of how things need to fit together. So you don't often know your requirements until you've actually tried to make something. So how many of you would do things completely differently if you started your game from scratch? And that's kind of the power of the prototype. And it isn't something you only do at the start of your project. That giant laser, that was a month before release. And it literally changed the entire way of playing the game. I didn't add mouse input until 18 months into development, following 6 months of thinking the new controller input was perfectly fine for everyone, and it really wasn't. So, to kind of wrap up, prototyping is not a phase in your project's life cycle. It is a mindset, bro. You embrace experimentation, and this all comes down to that phrase, fail faster. That's what this is. The more you prototype, the more you learn, and the better a project you'll have. So go forth and prototype right now. Go and do it. And I will answer whatever questions you have. Do we have any questions in the chat? Sorry, I probably sound quite gravelly. I am deathly ill. Yeah, reverting changes is just the same. Yeah, just mucking around is exactly it. That's the kind of right mindset to be in. Ideal length for working on a prototype is however long it takes. Most often for me, it's less than a day, usually an hour or two. But sorry, it's usually usually less than a day. But it can be up to a week. Just don't spend too long on it. If you're spending more than a few days, kind of work out what you're doing. So what triggers a prototype session? Generally, when I'm making a game, there are always decisions. So let me go back to the decision tree slide. So essentially, at various points in the game, you will often think, is it better if I do this or this? And that's what a prototype kind of is. It's your answer to that question. You might even have an idea. For me, what if I add a giant laser to the game? Does that make it more fun? Yes, great. There's a prototype. So basically just whenever you have a question about your game that needs answering. And for some people, I know that can be things like marketing. Does it sound better if I talk about my game like this or like this? You can prototype that. Next question, do you recommend feature prototype or approach from the very start? So just throughout the entire life cycle, like genuinely from the start, often you'll have an idea but don't quite know what it wants to be. So for jams, for example, I kind of start with like 2 or 3 30-minute prototypes, just to kind of work out what I find fun. Does that kind of answer your question, Meme? How many people should you share a prototype with? At least one who isn't you. That's the only rule I have. At least one person that isn't you. That's one person that isn't you. Ideally more, but just seeing somebody else try your prototype, you can kind of see what they're thinking. Hopefully that answers that one. For a more mature project, do you ever prototype new features, or in practice, is it easier to just build something onto the existing project? I usually start an entirely new project. The new Git branch is just my way of kind of toning that down slightly for a talk, because most people don't just want to start an entirely new project, but I find it very quick and it means I'm not attached to anything else. But when it's kind of late stages of development, then like that tends to be easier to do with with a you put me off there, Guitar Kid. Yeah. Usually the giant laser in Polyfury was within the same project, but there were 2 camera changes and an input change that were entirely new projects. And I think that's time.
All right, I think I can get started. So, this is the SAC programming language, otherwise known as lists, and why they're cool. Next slide. So first off, some info about me. My name is Levi, but I typically go by 6502 online or nobody. I dabble in just about everything on the planet, but the last couple of years I've been working on a tiny scripting language called SAC. Before we get into the syntax, I'm going to go over some of the goals that I had when designing it to better inform that. The first one is going to be SAC is simple, so a program executed top to bottom. There's no asynchronous, just write your code and it runs. Secondly, it's small, so the specification is intended to be minimal and simple to implement. Hey, calm down there. And the reasoning for this is because it was initially designed for a challenge between a couple friends for who could implement it better or first or whatever. And then it's also designed to be extensible. So because the language is small, it's not intended to be open-ended. It is really simple to extend or add features or mess around with or even prototype. And lastly, it should be easy. So you want to try and be able to learn it in like an afternoon if you're a new user. And so that informs a lot of the decisions about the syntax. And so let's start with the syntax. Next slide. First off, we're going to go into variables. Very simple, very JavaScript-esque. You use let, very dynamically typed. And there's not a lot of different types. So you have your string, number, decimal, and Boolean, which are from other languages. File represents just a file you load on the operating system, and byte, a file is a list of bytes. And so as you can see, there's also list, which is what this talk is about. None is what you'd expect from other languages. It's a null type. Moving on to functions. You declare them with the functy keyword, which a little bit interesting. A lot of people get mad about that, so you can also use func if you would prefer, but I like functy. By default, they return none, and they can be imported from other files just by adding the import name of file. The import keyword literally just copy and pastes the other file's contents into the scope, so you do have to watch out for some things there. Moving on to lists. So lists are an iterable form of scope, which sounds a little bit weird at first. Basically, they functionally act as both an object type and an array type. So they contain both raw data and named variables simultaneously, and you can access either by the index or the name of the variable. So you have, in the first example here, you're creating a variable called A, you're providing it a number, and then you have a list which contains both indexed content and that variable. So it is literally just a form of scope that you can iterate over. And as you can see, there's how you access the different types. Continuing on that, next slide. Lists get really interesting because you can put functions inside of them. So for example, in the first one, you were defining a function called add, which returns the sum of A and B. And so we can create a list that contains the number 3 and the function add, and then we can call the function based on the index of the list and pass in other info from the list to return data like in this weird metaprogrammy way. And then in the second example, a more advanced example, the list actually takes in the list that it's inside of as an argument and is able to return a new list. And so we have this example where we have a list of 0, 1, and 2. We add the function to the list, and then we're able to call it and have it return its value, which is a new list, assign that to the list, and you end up with a new list that is the function 1, 2, 3, and 4, which is the result of the function being called. And so you can do all kinds of crazy stuff, and even though classes don't exist in the language, you can do really, really interesting things. Next slide. So that's my conclusion. It was a fun language. It's designed as a language for me to use primarily, so that's why some things are a little bit weird. Lists are the fun thing, I think, and it's surprisingly powerful what you can do with it. Everything's on GitHub. The spec is floating around. There's a interpreter that's written in Rust you can download and try out. And if you have any questions, I am going to pop open a demo with the REPL and just see if you guys can break it or whatever. Hey, that was right on time for 5 minutes. So, yeah, questions. Impressive timekeeping. Yeah, I have 10 slides, so roughly 30 seconds per slide. How many arguments over knowable types have you had to sit through? Honestly, not as many as the arguments over why in the world did you use functy. But I think it's kind of fun. Feel free. Oh, yeah, right. I was going to pop open the demo. So here's a demo. Here I have the language pulled up so I can actually show you one really fun example of lists, which was over for Advent of Code. I used it last year, day one. Basically, you had some lines that looked like this, and you wanted to remove the text and sum the numbers. But the interesting part was that sometimes the text would be a number, and so you had to, make sure you didn't mess that up. And so I actually used lists as lookup tables for different possibilities, and yeah, solved it in pretty good time. Have I gotten it working on Mac OS? Well, it is written in Rust, so you should be able to if you have the Rust toolchain. Just do cargo install and pass in the Git URL, and it should just show up in your path. Are non-nullable types even viable in a dynamically typed language? Good question. Uh, I'm not sure I'm even processing what you're saying, so I can't really speak to that. Was it tricky to add editor support for the syntax? No, VS Code is really nice about it. And so you essentially just define some regex for what the different keywords are, and it just kind of works. I don't have a language server, so I don't have the really complicated stuff. That's a lot more complicated. Yes, it does that have anything to do with the book Crafting Interpreters? Yes, it does. I'm glad that someone called that out. Very few people happen to catch that. 2 minutes remaining. Okay. Yeah. Um, here's some functions I wrote for doing Advent of Code, I guess. How long? So, I started it a couple years ago. You can actually look on I sent the spec in the chat a while ago, and so you can actually you can scroll through the spec and you can see how many commits are. That's the first commit was like the first day. And so I think it's been around about 2 years of writing the spec. And originally there was another compiler written in Rust or interpreter written in Rust that didn't work very well, but that got replaced with Burlap, which actually works really well, really highly performant, about a year ago. When does the SAC.js interpreter launch? Well, Burlap supports both CFFI and WASM, so you can run it in a browser if you want by enabling WASM during the compile step for Burlap, and so then you can. Actually, I tried to use it for the GMTK jam last year using WASM, but I couldn't quite get Raylib to link properly, so it didn't end up working out. All right. Thank you guys so much for listening.
Okay, great. So I'm going to get started now. Okay, so hi, my name is Amit, and I'm going to show you how to design an S-tier puzzle, an S-tier AAA puzzle, actually. But first, we need to define what is an S-tier puzzle, right? So I'm not very good at words, but S-tier puzzles are one of those things where if you see it, you kind of know it. So these are some examples of screenshots of S-tier AAA puzzles that I pulled up. You have the Spider Ball Tower from Metroid Prime when you're in the phase on mines. You have the zany, mind-bendy levels that you can play cooperatively in Portal 2. And then you also have the more hand-holdy puzzles that you see in more recent games, such as the lift puzzle in God of War Ragnarok. All of these are what I consider to be S-tier AAA puzzles. They're all very different from one another, and each game gives the player different actions and mechanics they can use to solve them. However, even though on the surface these puzzles seem very unique from one another, they all share an underlying framework that is used to create these puzzles. The reason I know this is because I was taught how to make puzzles from the level designer who designed these very puzzles that you see on the screen. And while I don't claim to be a brilliant puzzle designer by any means, I would like to teach you today what my mentor taught me. So, making a AAA S-tier puzzle can be broken down into a 4-step process. The first step is called the objective. And by the way, these aren't like official names or anything like that. They're just what I call these steps to make them easier to remember. So, in the objective step, basically when the player walks into a room, the objective or the thing they want should be obvious. Because if the player doesn't know what the goal is, how do they know what to solve for? You want to make it as clear as possible what exactly the end goal is. In a lot of games, the camera will maybe zoom out and show you where you need to go, right? In other games, the player might just say out loud, oh, I need to power up these 4 terminals, right? Whatever the case may be, the player just needs to know what they're solving for. The second step is called the tinkering phase. In the tinkering phase, you want to give the player an opportunity to start tinkering with all the actions and mechanics that they have access to in the puzzle. What are the levers of the puzzles, right? What are the pieces that they can move around, and how does it affect the environment? This is a phase where the gears are figuratively turning in the player's mind. Do I press this button? No, that doesn't make sense. Do I move this here? No, that doesn't seem to do anything. This phase should take the player like 80% of the total time needed to complete the entire puzzle. Thirdly, we have the aha moment. This is the moment when the player thinks that they have solved the puzzle. They know how to put the pieces together. If you're watching somebody play your puzzle and they reach this aha moment, you will see it in their faces. Their faces will light up, or they might even say something out loud. The aha moment is that powerful. Once the player reaches the aha moment, they know exactly how to wrap up the puzzle and get to their goal. Now, if you're designing a puzzle and you've gotten to this point, you already have an A-tier puzzle right there. The aha moment is so key, it's really that powerful. And this is where most puzzles end, right? The player gets their aha moment, they know how to put the pieces together, and now all that's left is putting the pieces together. You see, actually putting the puzzle pieces together isn't that much fun. It's like if you had a jigsaw puzzle and knew exactly where each piece had to go. Once you figured it out, the act of actually physically putting the jigsaw pieces in order isn't that fun. And so in order to turn an A-tier puzzle into an S-tier puzzle, we add a 4th bonus step. And that final step is called the wrinkle. So as the player is going through the motions of solving the puzzle, you want to create a little bit of wrinkle, right? The player thinks they know what they're doing, but then something goes wrong. Something else suddenly pops up, and they must use another mechanic in the game that wasn't used in the puzzle itself. or they might have to use some bit of knowledge or another item from earlier in the game to solve the rest of the puzzle. It doesn't really need to solve. It doesn't need to change the puzzle in a dramatic way. It just needs to keep the player on the edge of their seat, and it reminds them that the puzzle that they're playing is played in the greater context of a larger interactive space. It bridges the gap between the puzzle and the greater game. And so I know we're short on time, so I'm just going to show you a quick example of how this framework is used to create puzzles in a AAA game. So I'm going to pull up the first kind of type of these puzzles from Spider-Man Miles Morales, and hopefully you can see this. So this is the beginning of the puzzle. I have it set at the exact moment. As you can see, you don't even see Spider-Man here, right? You see these trains. You see Spider-Man kind of saying in the subtitles, "Gonna have to get these trains back on track by hand." Like the game is already telling the player what they need to do. The player needs to put the trains back on track. So now that the player knows this is step one, the objective step, the player knows that they need to put the trains back on track. And so now that the player knows, they're going to go into the second phase of the puzzle, which is the tinkering phase. So I'm going to press play, and you're just going to see this Let's Player just kind of start tinkering. They're going to start running around, figuring out what to do. What are the actions that they have control? How does what they do affect, how the train is lined up? And so this is where you want to give. Again, this is what should take the most amount of time in the puzzle. And so we're not going to watch him because he kind of tinkers for a while. So I'm just going to skip ahead to the aha moment. But you're going to see that, he's just running around. And if you played this game, you know exactly what the solution to the puzzle is. You just need to line the trains up and then turn on the generator. And so we're on 122. So again, he's still tinkering over here. I'm actually going to unmute this video because I want you to hear how powerful the aha moment is. No one is telling him to do this. He does this automatically. Listen to this.
Wait a minute. Oh! Pull them back, drag him in.
Did you hear that? It's a. He actually said out loud, "Oh, he got the aha moment. Now he knows exactly what to do. He's going to try to put the trains in order." But again, this part itself, once he's reached the aha moment, this part isn't that fun anymore. He's already figured it out. And so all these AAA games that you play, these kind of puzzles, they all have that wrinkle added in as a fourth step. And so in this particular puzzle, you're going to see the wrinkle. The wrinkle is that train that's floating up above, you can pull it down, except it's going to go back up. It doesn't stay down. And so Spider-Man, the player, needs to remember that he can use his webs to actually jam the gears so that the train doesn't go back up. Again, that's not a part of the puzzle itself. It's just a wrinkle. And so he needs to use, so the player is using knowledge that they acquired previously in the game to finish off this puzzle. So that was my talk. I hope that you guys have learned a little something about puzzle design, and once you play games, AAA games and puzzles, that you recognize this framework and you can see the 4 steps. And that's it. I am open to any questions. I'm going to stop sharing my screen. Any advice for finding a balance between the player, enough levers to pull for a fun tinkering time without creating too many red herrings? So the answer to that question is playtest. Playtest. Give your game, give your puzzle out to other players, see how they play it, and just watch them, either get a recording, just see what they do. If they get, if too many players get too confused, it means it's too complicated. If it seems too easy, it's obviously too easy. You yourself, as the designer, you will not know whether the puzzle is hard or easy. Like, a lot of designers think like, oh, I know how to create good puzzles, or I know how to do this, whatever I think is the best answer, right? But no, there's no such thing as like good puzzle design. You just make as many puzzles as you can, give it to players, and see what sticks. That's honestly the answer to that. Interesting concept. Wondering what other design places a wrinkle can be applied to. So yeah, this is mostly in the context of puzzles. And it's just because once you have a puzzle, again, it's that final bit of the puzzle where like, oh, you know how it's solved. You're just kind of manually putting the pieces together. That's kind of boring. The wrinkle kind of just keeps you on the edge of your seat, and it makes it, it's what differentiates an A-tier puzzle from an S-tier puzzle. It's what kind of makes the puzzle more memorable. But I'm sure that there are other applications where you can create like a quote unquote wrinkle, right? You teach the player something, they get used to something, throw something random in the mix, right? Make them use knowledge that they acquired previously in the game, make them use an item that they acquired, make them feel more immersed in the game. How long is too long for the tinkering stage? Again, I think the rough ballpark is like 80%. I mean, it should be most of the puzzle, because once they get the puzzle, it's kind of done from there. So like 80%, 90%. Again, you can't have puzzles that are too long, because then, the player obviously has a limited capacity of what they can remember. And so generally, the simpler the puzzles, but add more of them, that's kind of the goal in making funner puzzles. Is a boss fight technically a wrinkle? I guess you can have, a lot of boss fights are like puzzles, and you can add wrinkles to them as well. I think I'm running out of time, so thank you so much, guys. I really appreciate you.